Bismillahirrahmanirrahim. Now, but so let's discuss how to find area under a curve through integration. This can later be area between the curves as well. Okay. Acha. Before I tell you how to find area under the curve, I need to show you, um, ask you something related to your O-level maths. Okay. But so suppose we have a line here. Let's say this is the line y equal to 4. Okay, and this is 0, this is 4, and here you have suppose 10. Hmm? So what is the area of this rectangle, bacho? Hmm?
40.
Yeah, that is 40, because you know that this is 10 and this is 4. So this area is equal to 40 units. I'm not writing the units right now. Now let's look at another example here. Suppose you have a line here. Now this is, let's say this is 10 here, this is 5 here, okay, and this is 0 here. So the equation of this line is y is equal to minus half x plus 5. Okay, this is y is equal to minus half x plus 5. Now suppose I want to find the area of this triangle. So what will be the area of this triangle?
25.
25, yeah, because you know that this is 5 and this is 10, and then again area is going to be half into 10 into 5, so that will be 25 units. Okay, just be sure that if I just wrote the equation mentally, I believe this equation is representing this line here. Okay, now just one more example. Now suppose I have here something like this. Okay, now this is, suppose the equation of this line is y is equal to um, 2x plus 4. Okay, you have 4 here, this is 0, and then suppose this is your 10 here. Okay, and this point is going to be 10 comma 24. Okay, this is 10 comma 24. So if I ask you that how to find the area of this trapezium over here, so what will be the area of this trapezium? Hmm?
140.
Okay, because you have this as 10, this is 4, and this is 24. Okay, so the area of the trapezium is going to be half into sum of the parallel sides, that is 4 plus 24 times the height. So this is,
Sir,
half.
height is 10.
Oh, sorry. Thank you. Thank you. Height is 10. This is half into 28 times 10. So this is 2 5s are. So you were correctly saying this is going to be 140 units over here. Ajay Bacho, the thing is that you can find all these areas using the formulas that you people have learned. Now, what if you have a curve, for example, uh, let's say you have a curve like this, okay, and maybe you want to find all this shaded area here, okay. Let's say this is all the shaded area. So how to find this area over here? You see, mathematicians are so cool. They pick the smaller things, they make the rules, and then they apply that onto everything that they come across. Now look at this. Let's go back to this first situation here. If you integrate this y, which is 4 over here, okay, with respect to x, from the limits, to the limits from 0 to 10, for the limits from 0 to 10. Now, what is the integral of this 4, bacho? Mhm.
4x.
4x, okay, good. This is 4x. So you see that limit from 0 to 10. When you apply the limits, you get 4 into 10, that is 40 minus 0. You see that you get the same answer, that is 40 over here. Okay, so this works in case of a horizontal line. Let's see if it works here as well. Okay, so let's integrate this from 0 to 10. And you have, it is going to be minus half x plus 5. Okay, minus half x plus 5. So when you integrate it, you get minus x square over 4, and then you have 5x. Okay, and then you have the limits from 0 to 10. Let's apply these limits here. You have minus 100 over 4 plus 50. And then when you put 0, both of them will, like this, would be 0 plus 0. Okay. So guys, you have minus 25 plus 50, and that is going to be equal to 25. You see that this matches with this 25 over here, Hannah. Isn't it so cool? You will see that this will be matching in this case as well. If you integrate this limit from uh, 0 to 10, and the equation is 2x plus 4. Okay, this is 2x plus 4. So this is going to be x squared plus 4x, and limit is from 0 to 10. When you apply that limit, you have 100 plus 40 and then minus 0. So that is going to be 140. So this means integration can be used to determine the area under a curve. And now, if you have the equation of this curve over here and you have all these limits here, you can easily find the exact area over here. ठीक है बच्चों? So this is how you find the area under a curve through integration. You were basically, there are four cases. There are in fact more than four cases, but four basic cases here. When you have to find the area between the curve and the x-axis, then the rule that you apply is that is y dx, limit from a to b. That is the formula that we have used here, that area is limit from a to b y dx. Now don't be worried about that I'm writing this y dx. This is why, because here you had y equal to 4. So you have integrated this 4. This is representing your y, okay? This expression over here is also representing your y. This is also your y equal to this, okay? So that is why the rule says that if you have to find the area between the curve and the x-axis, then this has to be y dx. And you will, I mean, inshallah, you're going to see that if you have to find the area between the y-axis and the curve, then the rule is going to be, the formula would be that area is going to be limit from a to b, and that will be x dy. You will just see that. Just wait for this. Okay. Acha. Now here are some key points that you need to remember while finding the area between a curve and the given axis. Okay. Now suppose you have a curve like this. Okay. Now first of all, if you're finding the area between the curve and the x-axis, then you must have these vertical lines which are known as the ordinates. These clearly determine that what are the boundaries of this area. One boundary would all obviously be the curve over here. Second would be the x-axis. The third and fourth have to be these ordinates over here. Okay, so this is between the curve and the x-axis. ठीक है ना? And if you have to find the area between the curve and the y-axis, now suppose, just a minute, suppose you have a curve like this. Suppose you have a curve like this, okay? And you want to find the area like here, you want to find this area here, okay? So you should take your notes very carefully. So this would be your, like, that is how you will have your ordinates over here, okay? I was telling you that there are four basic rules of finding this area. Let me draw all those four basic rules, and then I'll give you the formulas for that as well, okay? Now that is a third rule when you have to find the area between the curve and the x-axis, but this area is below the x-axis. Suppose you have to find this area from A to B. Here is the third case, okay? And then the fourth case is when you have to find the area between the curve and the oh, and the vertical axis. And this vertical axis is, come on, yeah. Okay. And suppose you have a curve like this, and you want to find the area here, and this area is towards the left side of the vertical axis like this. Okay, so here is your A and here is your B. Just note it down. I'll tell you the details of this in the next segment, inshallah. Okay, here the area would be limit from A to B, and this is y dx. Here the area would be, we'll have to put a minus before that, because if you don't put that minus, your area will be in coming in negative here. Okay, and when you have to find the area between the curve and the vertical axis, okay, so the rule is going to be, this area is going to be limit from A to B. You will have to make x the subject of your equation. Okay, and for this one, again, this area is towards the left side of this vertical axis. So this area will be like this, minus limit from A to B, and this is x dy. Acha, later on you will learn that if you switch the limits, you can get rid of this minus. Like if you write it as limit from B to A, so you can avoid writing a minus. And similarly, in this case, if you just switch the limits from B to A, this minus will be gone. Okay. So guys, these are the four basic rules of finding the area with, under a curve. Okay. Area between a curve and the horizontal axis or the vertical axis. Now let me take you to the exercise, and then we can try some questions from the exercise. Okay. Okay. Let me scroll this up and see which questions we have here. Okay, here you are. Now, I'll just be writing the notations, and then you can, complete that working, and you can find the value. Now, here the area would be limit from 0 to 4, and this is between the curve and the x-axis. So you can, this is x cube minus 8x square plus 16x dx. If you find this integral, that will be the required area. And as I told you, that you must be very good at the definite integrals. Here you see that this 1 and 3, these are the ordinates over here. Okay, so this area over here is going to be limit from 1 to 3, and this is 2x plus 3 over x squared. You must know your integration now. You know your basic integration, you can do anything. Look at this C part. This is limit from 0 to 5. This area is below the x-axis. So either you put the limits in the right order, but you will have to put a minus before that, okay? This is x squared minus 5x. And if you don't want to write a minus here, then you can simply say this is limit from 5 to 0, and this is x squared minus 5x, and then you can integrate it. Okay, so just keep on taking the notes. I'm just leaving the integration part up to you people. ठीक है ना? अच्छा, now look at the situation here. Let me now look at the sixth question here. Okay, guys, please look at this very carefully. Now, this is the situation where you have to find the area between the curve and the y-axis, the vertical axis. When you have the vertical axis, your ordinates would be the horizontal lines, unlike the situation when you have to find the area between the curve and the x-axis. Here, if you have the ordinates, they have to be the vertical lines like this. If you can see this, x equal to 1, x equal to 3. So these are the ordinates here. Okay. Now look at this situation here. We need to find this required area, bacho. So the thing is, your equation should be x equal to blah, blah, blah. So you will make the subject x first of all. So this would be, you will square both the sides. This will be 2x plus 1 equal to y squared. This is 2x equal to y squared minus 1. And x is going to be half into y squared minus 1. So now we're ready to find this area. So, bacho, this area will be, therefore, limit from 1 to 3. You can write this half outside here, and this is y square minus 1 dy. So once you do that, you integrate this with respect. Let me do that for you people. This is limit from 1 to 3. Okay, this is y cube over 3, and this is minus y. So you apply the limits, you will get that required area. People, are you understanding what I'm trying to convey to you people? Hmm? Yes, बच्चों? Hmm.
Yes, sir.
ठीक है ना? अच्छा, so this way, guys, you have to do all this work. ठीक है ना? So I'm just finishing the segment up to this. You have to try these questions. And the next segment, we shall discuss the problems. Okay. This is the exercise. Exercise. What is the exercise? 9F that you people have to try. Okay. Thank you very much.